Yeah, we're starting actually. There was some problem in starting. Yeah. Okay, so I'm going to share my screen now, and I hope all of you know how to join joinpd.com. Okay, please use your browser to join joinpd.com, and the code is XXFMJN.
Sir, we are not able to hear you, sir.
Is it?
Yeah.
So how are you able to answer? Okay, is it my voice is low or
Very low, sir. It's very low.
No, I think your voice is clear.
No, no, it's very low for me, sir.
now? Is it fine?
Now it's fine, sir.
Okay. Okay, how many of you joined? Okay, let's see. Okay, so shall we start? I think I don't know like how many of you joined, but yeah, I'm assuming that all of you have joined, and we start. So this is our first question. This is, let x1 x2 dash 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 x100 be independent identically distributed random variables, each with expected value mu, which is expectation of xi. So expectation of every random variable x1 x2 x3 to up to x100 is equals to 3, and variance, which is sigma square of each random variable, is same, and which is equals to 9. Okay, so approximate the probability x1 plus x2 plus dash 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 plus x100 greater than 100 using the central limit theorem. So you have to find the probability for the sum of these 100 random variables. This sum should be greater than 100 by using the central limit theorem, and write your answer in terms of fz. So let's say your answer is fz of fz of, let's say, 3. Okay, so fz of 3. So how will you write in that text box? You can write fz of 3, or you can write f of 3. F of 3 also is fine. So we'll wait for 5 minutes, and then we'll discuss the solution. Okay, only 8 of 24 students have given the answers. I'm seeing is there are total of 54 participants in this.
Can you speak a little louder, please? Your voice is very low.
Okay, so what I'm saying is only 9 students out of 24 has given the answers, and total 55 participants I'm seeing here. So others haven't joined, I think, the this joinpd.com. Others, please join the joinpd.com and try to if you want more time, just let me know. Okay, so but 10 students have given the answers now out of 24.
Your voice is still low, sir.
I don't know. One minute, okay, I'll see. I'll check.
It is low for everyone, sir.
It's really very bad.
Okay, now is it fine?
No, sir.
Huh? Still no? Huh?
No, sir.
Okay, just wait. Okay, now Is it okay now? Hello?
No, sir.
No change, sir.
Ninja. So I think there is a problem in network only, I think. Because I have changed my earphone. Still, if it is not, then there is a problem in network,
You
I
can
think.
speak little louder, sir.
Yeah, I'm trying to speak in little louder, but I don't know. Is
It's
it? Is
clear
it?
for me actually,
I
but
can
yeah,
hear
Ah,
you, sir.
so
I
maybe
can
you
hear you.
guys. Yeah. So one thing
It's
you can
low,
do.
but I think it's manageable. I think so.
Okay. So yeah. So others, if you are not joining with the, can you use the earphones?
You
Sir,
Because I see
even after wearing earphone, you are not that much audible, sir.
with earphone it is not audible. You're saying.
No,
yes, sir.
not that much audible, yes, sir. I think most of us.
Means we have to really concentrate hard.
Okay. So okay, I can't do anything that much about because I have changed my earphone right now itself. But still, maybe then there is a
It's
network
okay,
issue.
sir. We shall manage.
Sir, it is audible, but it is low, but it is audible.
Okay. Okay. Fine. Yeah. So yeah, so how many of you, 11 students out of 26 given the responses? Okay, is there any problem in this solving this question? So first of all, you know the formula for central limit theorem, right? How to use the central limit theorem? Do you know about it? So consider this x1 plus x2 plus dot 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 plus x100 as a sum. So this sum as a newer random variable. So consider this as y. So y is equals to x1 plus x2 plus until x100, right? And each x1, so each xi here is having the mean equal to 3 and variance equals to 9. So our standard formula or central limit theorem is y minus n mu divided by sigma root n. So where mu, if you are going to use here, it's a mean for each random variable, okay, and sigma is the standard deviation of each random variable, right? So if you plug in those values, you will get the answer for probability that this sum, which I said y is greater than 100. So you have to do that changes, like y minus n mu upon sigma root n, right? So same changes you have to do in the right hand side, whatever you are doing in the left hand side. So what will happen? So this sum, so this random variable will convert into a normal distribution. So it will approximate to normal 0 1, which is a standard normal. So I think now you can try, and because see, most of the questions today are basically based on central limit theorem and weak law of large numbers. So if you understand this question, then only you'll be able to solve other questions.
Excuse me, sir.
Yeah.
Sir, can you please tell me how to access this question? I mean the link or
Okay, so you can go to joinpd.com. So yeah, you can open a new like window or tab in your browser, and you can write joinpd.com. Click on that and use this code, the right top right code, right? XXFMJN without space in that. So you'll be able to see those questions there, and you can give the answers there. Let me know if any problems are there. Okay. Okay, take 1 or 2 minutes more, and we'll discuss the solution later on. Okay. So others who have joined already, joinpd.com, please try to give the answers. So I think I have already explained what you have to do. Just use that information and try to solve this question. Okay, I think we'll discuss the solutions. So yeah. Okay, so we know that x1, x2 to x100 are all ideal distributions. Okay, and with the mu equal to 3 and variance equals to 9. So we wanted to find the probability that so it's an approximate one, probability that x1 plus x2 to x100 which is greater than 100. Okay, so consider this so consider this x1 plus x2 to x100 as s100, or you can consider it as y, right? Okay, am I audible now?
Yes, sir.
Okay,
Yes, sir.
slow, right? Okay, so using CLT, so I told you y minus, so what is CLT? So you have to subtract the mean, right? And you have to divide it by standard deviation, so that it will approximate to a normal distribution with mean 0 and standard deviation 1 or variance 1. Okay, so expectation of s100, which is expectation of x1 plus x2 to x100, right? So which is nothing but expectation of x1 plus expectation of x2 plus expectation of x3 up to expectation of 100, and all are IID distributions. So you can say that it's 100 times expectation of xi. So we know the expectation of xi is 3, so 100 into 3 is 300. Similarly, we can find the variance for this s100 or variance for y. So how we can find it? So it's variance of x1 plus x2 up to x100, right? So it is nothing but a variance of x1 plus variance of x2 up to variance of x100, which is 100 times variance of x1, and we know that variance of x1 or variance of xi is 9, so 100 times 9, it's 900. So expectation of s100 is 300, expect variance of s100, which is equals to 900. Now what we have to find is, we have to find probability that s100 is greater than 100, which is equals to probability that s100 minus mu, which is expectation of s100, s100 minus 300 divided by root of 900. Okay, which is greater than. So what I told you, whatever things you are going to do in left hand side, same things you have to do in right hand side. So you have subtracted mean, right? So from s100, so same thing we have done here, 100 minus 300, and you have divided by root of 900, which is nothing but 30. So 100 minus 300 divided by 30. Similar thing, whatever we have done in left hand side, to convert it into a normal 0 1 distribution, we have done the same thing. So probability, so this term, it is called as a z. So probability that z is greater than minus 200 by 30. So which is nothing but 1 minus fz of minus 20 by 3. So that should be the correct answer, and I think it should be 1 minus fz of minus 6.667, something like that, right? So that is the correct answer. So you
Sir,
So,
know
but,
how.
sir, but fg of minus 20 by 3 itself will be equal to 1 minus fg of 20 by 3, na? Right, no?
So what is fz of minus 20 by 3? So the portion which is
On the
uh,
left side, na?
left side of that minus 20 by 3, right?
Yeah. But
And
ultimately, it will be equal to 1 minus fg of 20 by 3, right? Because
uh,
on the in the
yeah,
table also,
same
it
thing.
is
Yes,
like that.
yes, yes. So because yeah, since it is normal zero is a symmetric curve, right? So that
Yeah.
minus 20 by 3, you can same thing you can do to a right side also. So it will
So,
be
yeah.
20 by 3.
Yeah.
So
So
same
just the
thing.
answer will be exactly fg of 20 by 3 also is correct. Now, just
Correct.
I'm asking for my understanding.
Yeah, yeah, correct. It should.
Okay. Okay. Thank you.
So shall we move to the second question?
sir, one more doubt.
Uh-huh.
Actually,
Okay.
S100 variance is 9 into 99, na?
Why 99?
10 minus 1. Na?
Huh? No, no, no,
Yeah,
no, no.
variance of S100.
So okay. So it's not a okay. X1 is a different random variable, right? It's independent and identical distributed, right? So x1 x2 are different random
Right.
variables. So let's say you have only x1 plus, so let's say y is equals to x1 plus x2, and I wanted to find the variance of y. How you are going to calculate variance of y? Variance of x1 plus
Right,
variance
sir.
of x2, right?
Yeah.
Huh? So and if
Right,
x1
sir.
and x2 are same, that's what. So whatever you are doing is that is a different thing. That is for samples, right? What we have done in the statistics. So that is different one. That is sample variance. Okay.
Okay.
Okay. So
Right.
now we'll move to the question.
Sir?
Huh.
Sorry, I have a question here. The gentleman earlier was asking if it is if FC of minus 20 by 3 is also the answer, but how can that be the answer? Because one is going to be
not FG of minus 20 by 3, it's 20 by 3 only, positive side. So if you draw the normal curve, right? And if you, because it's 0 1 normal curve, right? So the
correct.
half portion is like let's say 0.5 probability is on the right side of the mean, right? Right side of the 0 and left
Correct.
side 0.5, correct. So where that minus 20 by 3 point will come, somewhere to the left side. And what is fg of minus 20 by 3? Whatever from minus infinity to that point, right?
Correct.
That probability.
Correct.
So and this answer is 1 minus fg of that probability. So that means whatever the thing, like whatever probability remaining to a right side of that minus 20 by 3, right?
Yeah. So it still is 1 minus fz of 20 by 3. Fz
Yeah.
of 20 by 3, if I take it from any of the tables, it's still going to be subtracted from 1, correct?
Okay. So fg of fg of 20 by 3 will be from minus infinity to plus all that thing, right? So only fg of 23 will be what? Okay, just let me wait. I'll just join that writing device here. We will try to solve this. Just wait 2 minutes. Okay, 1 minute. I'll just open this. Okay, my screen is visible, right?
Yes, it is.
Just wait.
What is the question, sir?
So the question is the answer which is coming like 1 minus fg of 20 by 3, right? So I'll just, so that minus 20 by 3 will be here somewhere, right? Because this is 0 1 normal curve, right?
Correct.
0 1. Now 1 minus fg of minus 20 by 3, this is the answer. So this will be minus 20 by 3, right? So and what is fg of minus 20 by 3? This one is this portion, right? And 1
Yeah.
minus fg of 90 by so that 20 by 3 is this portion. Okay. Now what we are saying is, so this will be 20 by 3, correct? Somewhere
Yes.
here. And what is 20 by 3? This is whole this area, right?
Yeah.
Okay. So which is nothing but what? This area is fg of 20 by 3. Is it not equal to this portion? So is it not equal to this portion?
It is also taking the portion which is after 20 by 3 point, sir.
Which one? Which one?
Correct.
So what I'm saying is so this minus 20, so okay, this is minus 20 by 3. So this black portion, right, whichever I shaded, this portion and say this portion.
Sir, not only that, even area after 20 by 3, that is also getting included. The area after that also, that should also be included, no, sir. When it is 1 minus fz minus 20 by 3, then that should also be included.
What I'm saying is, what is this fg of 20 by 3 is what?
Right hand side.
This one, right?
The right. No, no.
Yes, up to that point.
No,
Up to that point. Yes.
f0 20 by 3 is this one, na? Left side, left hand.
Yes. 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 Yes.
Yes,
So
sir.
it will go from minus infinity to this point. So this area, okay, this area and this area, is it same or different?
Same.
So what? So I can say 1 minus fz of minus 20 by 3 is same as fz of 20 by 3. Can I say this?
Yes.
But
Yes.
sir, in case of fg of 20 by
Yes,
3,
sir.
the entire area will come, na? Even the left side wala,
This one, na?
beyond that, beyond the minus 20 by 3 as well
So
will come, na?
in this case, fz of 20 by 3, it will come everything, right? To plus
Oh, 1
infinity,
minus. Oh, yeah, right.
right?
Okay.
So everything is same, no?
Now, sir, in case of 1 minus fg of minus 20 by 3, that minus 20 by 3 ka right portion only will come, na? But in case of, if you say fg 20 by 3, all the left side of 20 by 3 will come. So even the left
Yes.
side of minus 20 by 3 also will
And
come,
both
na?
the areas are equal. No? Both the
Equal.
areas are
But
equal.
so is it?
No,
In
no.
case of the former, this is going
No,
to plus infinity.
the left side of
Okay,
minus
okay,
20 by 3 also will get included, na, in this case.
okay.
Yes, but
We'll
sides will change.
okay. We'll see. We'll see. Once again, we'll see. So what I'm saying is, let's say because this is still right. So okay, it will start with minus infinity, correct?
Right?
And here this will go up to plus infinity, right?
Yeah,
So here it's my minus 20 by 3. So
right.
this area is from minus infinity to minus 20 by
Perfect.
3,
Yeah,
correct?
yeah,
So whatever left, so 1 minus fz of minus 20 by 3 is this. The
exactly.
portion up to infinity.
Yeah.
Okay. So let's say this probability is something, let's say, what, okay, I don't know, okay. But let's say it's 0.1.
Mm-hmm.
So whatever left here, this side is what?
0.9.
0.9, yeah.
Okay, now let's say another area. So again, this will go from minus infinity to plus infinity. That is true, right?
Mm-hmm.
Okay. Again, since it is symmetric, so I can say that okay. First of all, okay, this is 20 by 3.
Yeah, yeah.
Uh,
Oh, it's symmetric. That's why it's okay.
yeah,
Okay.
that's what I'm
Got
saying.
it.
So this
Okay,
symmetric.
got
No,
it.
so whatever this portion here from
It's similar to that one.
it should be right because
Yeah,
if
yeah,
it
yeah.
is symmetric,
Exactly. Yeah,
then this
right.
probability also should be 0.1. And
That's why even in those tables also, if I see minus
yeah.
thing and the plus thing, it okay, got it.
So
Thank you.
that is why we are using this. Why we are doing it is to standard
Standard 0, 1, yeah. Okay,
because of
got
this
it.
reason. So
Okay.
I can say that 1 minus fz of minus 20 by 3 is equal to what? Fz of 20 by 3.
Okay, thank
If
you,
you
sir.
write this answer also, it is correct, and if you write this answer also, it's correct.
Okay, thanks.
Okay.
Can you come to question, sir? Second last line I have a doubt, sir.
Where?
The second last line, sir. Yeah, this one. That yes, 100 minus 300 divided by square root 900 is greater than 100 minus 300.
What
So
is
from
doubt
where
here?
this one is coming, sir? Because in formula it is delta square root n mu divided by sigma, right?
Okay.
Sigma root n.
Okay, so this is your formula, right? What if you wanted to convert?
Yeah, I'm saying y minus n mu divided by square root n sigma.
Okay.
Greater than.
Okay, whatever. This side it's okay. First of all, we'll try to figure it out. This one. So this is my x1 to x100, right? So what is n here?
Yes.
100. What is mu for each xi is?
3, sir.
What is standard deviation for each xi?
3.
Okay. If I wanted to put here y minus n is what?
100
mu
into
is
3.
3. Root of 100
into
root
3.
of sorry, not root of so it will be 3. Okay.
Into 3.
Right. So if you
Yes.
convert it, so what it will become? Y minus
330
divided by 100.
30.
So if I wanted to shift,
That is clear. That is become 900. Is square root 900. Yes.
so this is same thing.
I'm saying the right hand side, sir. No, I'm saying right hand side. After that, greater than.
Okay,
The formula is delta square.
What is formula?
Formula is delta. Delta is square root n mu divided by sigma.
Okay, you are getting
Greater.
confused actually. So this delta is nothing but 100 here, no?
Yes.
So So that formula is something like this, na? If let's say y minus n mu divided by sigma root n, right, greater than. So it was actually previously it
Greater
was
than
y.
delta
What is
square root n mu by sigma.
1 minute, 1 minute. So this probability of y is greater than delta. Okay, we are going to find this one. So this delta minus n mu divided by sigma root n, right? So this delta is 100 na here.
Delta n mu, sir, not minus. Delta n mu.
Mhm.
Because it's in minus
Simplification, it becomes that.
So what is delta here? Okay, in this question, what is delta? Can you tell me?
100. 100.
100.
So what you are saying is 100 into n mu, huh?
Yes, I think
I think
the formula it is written that
100 minus n mu.
that formula is different one there. Okay, what I'll suggest you is you just go through the lectures once again. Okay, maybe I'll just show you.
I'm reading the formula from the lecture sheet only.
I know that formula, but how that comes? Have you seen that first of all? See, this
Derivation is not
formula.
there.
I think this formula you are talking about, right? Y minus n mu is greater than delta n mu.
Yeah, just
Right.
scroll a little bit down. Scroll a little bit down. Further down.
Okay.
Further down it will be there. Further.
This one, na?
Yeah, this one.
Okay.
This.
First
Yes,
of all,
yes.
try to see this one. Here, what is asked
Mm.
here? What is probability that y minus n mu is greater than delta n mu? Okay. So
Mm.
that delta n mu, okay, this delta n mu you are seeing, right? So that delta n
Mm.
mu is 100 here actually. All delta n mu
Mm.
is 100 here.
Okay.
Then only
It is not only delta is not 100. It is entire three
Yeah,
product of three factors is 100.
yeah. So don't get confused with this term delta n mu. Just think about, let's say if I wanted to ask you what is probability that y is, okay, that n mu is also not there. So here the question is this one. Okay, 1 minute. So this question is y is greater than 100. This is question, right? And what is your formula?
Right.
And what I have asked there in that question? Probability that y minus n mu is greater than delta n mu. Correct? So is it similar somewhere here?
Yes,
No,
sir.
right? No, it's not similar, na? This
No.
y is different. This, okay, here it was subtracted with n mu, and so this probability was different. The ask probability is different, and this one
Mm.
is different. So for this thing, you have to convert it into the standard normal. And how you are going to convert into standard normal is you have to subtract the
Mu.
expectation, that is mu,
Yes.
right? And you
Yes.
have to divide it by standard deviation.
Sigma.
So when you
Yeah,
do
sigma.
this, then it will be normal 0 1, right?
Mm.
So in our
Mm.
question, when we asked y greater than 100, in that question, what was expectation of x? So not expectation of x, it's expectation of y, sorry. So what was expectation of y? So it was what?
Mm.
Expectation of x1 plus expectation of x2, right? And
So
to
300.
300. So that will become 100 times expectation of x1. Why? Because this is IID samples,
Yes.
right? So
All
this
of them are
becomes
same. Yes, all of them are same. Yes.
so
300.
the procedure you have to follow is this one. First of all, you have to find the expectation of
Mm.
given y, right? And then you have to divide it by standard deviation of
Yes.
that y. Okay, don't directly use
Okay.
that
So it
formula,
is y.
because that is not near that similar.
Okay.
What
So it is becoming.
correct?
Okay. So let us complete it. So it is becoming y minus 300. Y minus 300 by sigma.
So what is sigma there? So first of all, you have to find variance of y, right?
Sigma is 3.
So variance of x1
Mm.
plus variance of x2 plus variance of
Mhm.
x100, right? So this is a 100 times variance of
Mm.
x1. So 100 into what is variance of x1? 9.
9.
It is 900. And then what will be
900.
the standard deviation of y?
30. 30. 30.
30. So what I will do, y minus 300, right? Mu divided by standard
Yes.
deviation, which is 30. So same thing I'll apply
Yes.
over 100. So it will be 100 minus 300 divided by 30. So this is minus 200 by 30, which is again going to be
Okay.
minus 20 by 30. And this term, right? This term is what? Is z.
Mm.
So our probability become.
No, this part is clear, sir. So could you come back to that sheet, presentation sheet? Could you come back to that sheet?
Okay, 1 minute.
Yeah. So now, when that formula.
That one.
So which question are we discussing? Right?
The first one only. First one only. Yes. Okay. What's problem here now?
Okay, fine, sir. Let us
Fine, right? Same thing, right? Okay. Okay. So the second question is, let x1, x2 to x100.
Can I request a pause? Just 1 second. Going back to the curve where you showed 1 minus fz of minus 20 by 3. The part of minus 20 by 3 is clear. 1 minus fz of minus 20 by 3 is also clear. That, as we assumed, it's going to go to 0.9. So where is this f of 20 by 3 going to be equal? Because f of 20 by 3 would mean left side of the curve, or is it the right side of the curve is what my
Okay.
question is.
What is the so what is fz of 20? What is this? Or 20 by 3 is what? It is CDF, right?
Correct. It's a CDF. So I come from the left side.
Yeah.
Okay. Okay. Got it. Got it. Got it. Thank you. Thank you.
CDF. Correct?
Yeah. Yeah.
Okay. So now this is your question. So let x1, x2 to x100 are IID normal 0, 2. So here mu is 0 and sigma is root 2. Now evaluate probability that x1 square plus x2 square dash 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 plus x100 square, which is greater than 220, and approximate by using CLT. And you can use this value. Okay, one more hint in this question is, you know that if x1, x2, so each xi, if it is IID normal, right, then square of x1 is what? It's a gamma distribution, right? Gamma, alpha, beta. So what is alpha and what is beta there?
Alpha 0, beta 2.
So you understand, right?
Alpha 1 by 2 and beta 1 by 4.
Correct. Alpha is
1 by
1 by
sigma square.
right. So use that information to solve this problem. So okay, so this is like I'll give you 5 minutes, and exactly after 5 minutes we'll start discussing the solution. It's already 6:45. Okay. So I think okay, same thing you have to follow. Just think about that it's a gamma distribution. Okay, then only you'll be able to solve. And you know this another formula also, right? If each xi square is let's say gamma alpha beta, and then what is the sum of n xi?
N alpha beta.
N alpha beta. Okay, that information you have to use, and you will be able to solve this problem.
कॉल येऊन येईल कस्टमरचा. कोण नाहीत म्हणून सांग, गावाला गेले म्हणून सांगायचं सर. हे बघ, असं जर 6 वाजता मी तुम्हाला क्लास आहे वगैरे म्हणून सांगितलं, तिकडं कोणी आलं तर सरळ गावाला गेलेत म्हणायचं. मी फोन स्विच ऑफ करून बसायला, म्हणजे एअरटेलचं सिम बंद करून बसायला. तिथेही दणदण वाजवून चालू. त्या मूर्खाला सांगितलेलं आहे मी सकाळी येतात किंवा दुपारी येतात, मी मुद्दाम या टाइमला. हो, मागे एकदा आलतं, तिकडूनच आलतं 2-4 दिवसात. तिकडच्या गेटनं आला असेल ना. मग तू इकडे कशाला आली? हो, तू इकडे कशाला आली? तू त्याला बघून येते म्हणून सांगून आलतीस का?
Okay, only 7 students responded. Okay. Oh, here, yeah, you can directly write the answers. Fine. Okay, take 2 more minutes and we'll discuss the solution. Okay, I think we should see the solution now. It was same problem, but yeah, slight twist was there, right? So shall we discuss the solution now?
Yes, sir.
Okay, everybody's okay, or you wanted some more time?
Yes, sir.
Okay, fine then. Okay, we'll see the solution now then. Now same, we have x1, x2 to x100, which is IID normal 0, comma 2. What we have to find is, we have to find the probability that x1 square plus x2 square plus up to x100 square greater than 220. Okay. Now what I said is, each xi is what? Each xi is normal 0 to distribution, right? And what we know is xi square. So if xi is normal 0 to distribution, then xi square is what distribution? It's a gamma distribution with alpha equals to 1 by 2 and beta equals to 1 upon 2 into 2, right? So that we know already. So and if I know that alpha is equals to 1 by 2 and beta is equals to 1 by 4, then how to find expectation of gamma? So we know what is expectation of gamma. So expectation of gamma distribution is alpha upon beta. So here alpha is 1 by 2 and beta is what? 1 by 4, right? So alpha 1 by 2 divided by 1 by 4, which is nothing but 4 by 2, which is equals to 2. And what is sigma square there? So sigma square or variance of gamma distribution is what? Alpha upon beta square, right? So alpha is 1 by 2 divided by beta square is 1 by 4 square, which is 1 by 16. So 1 by 2 upon 1 by 16 is 16 by 2, which is equals to 8. Now we know that uh, this alpha and beta, right? So what we have to find is, we have to find probability that x1 square plus x2 square plus x100 square. So consider this x1 square as, let's say, y1, okay, and x2 square as y2. So what we have to find is probability that y1 plus y2 plus y100 is greater than 220, right? No. Now if you apply this, so how we are going to apply on that? So by using the central limit theorem, okay, I'll try to write it once from this part. Okay. Now what we know is xi square is, so I will consider yi, which is gamma 1 by 2 1 by 4, right? This is alpha, this is beta, and we know that expectation of alpha, sorry, expectation of gamma distribution is alpha by beta, which is 1 by 2 divided by 1 by 4. Now it will become what? 4 by 2, which is 2, right? And sigma square is alpha upon
8.
beta square. So it is 1 by 2 divided by 1 by 4 square is 1 by 16, which is 16 by 2 is 8. Okay. Now we know this one. Now what I'm saying is, what we have to find, we have to find x1 square plus x2 square plus x100 square, which is greater than 220. We wanted to find this. Now consider this x1 square plus x2 square as y1. Okay. So it is y1 plus y2 plus y100 greater than 220. So this is similar problem as what? Provided that x1 plus x2 until x100 greater than some number, right? Similar problem, right? In that case, what we have to do? We have to subtract what? Expectation, right? So so let's say this is s. Entire thing is s. So s minus mu. What is mu there now? This is expectation of what? Y1 plus expectation of y2 until expectation of y100, correct? So this is 100 times expectation of y1. So what is the expectation of y1?
2, sir.
2, right? So this is 100 into 2, which is 200, correct? And what is similarly, what is variance of this? Is 100 variance of y, which is 8. So that what is standard deviation then? Under root 800 or 100 into 8, correct? This is 220 root 2, right? Because 100 root of 100 is 10 into root of 8 is, I can write it as 4 into 2, which is again 2 outside, so 20 root 2, right? This step is okay?
Yes, sir.
Everyone, if you have doubt, right, just let me know at that point itself, so it will be okay. Now same whatever we have done here, this left side, we have to do same thing on the right side. Right side, what was there? It was 220. Now 220 minus what? 200 divided by 20 root 2. Okay. Okay, at until this step, anyone is having any doubt?
So it is as good as taking the expected value of the next gamma one, that is n wala gamma, whatever 100 or thing.
Yes, you can do
So
that
it is
also.
as good as the
Yeah,
same thing.
yeah, sum of independent n independent
Yeah,
gamma.
right.
So gamma alpha beta is what? We know that alpha n alpha upon sorry. So it will be gamma n alpha beta, that distribution, right?
Yeah.
So you can do that also. It's fine.
Okay.
So but sometimes if you forget, right, this is a basic procedure what I'm trying to show you.
Right.
So this, yeah, so this thing, right, this entire thing is what now?
In the normal 0 1.
Right. Yeah, which is normal 0 1. So I'll write only n 0 1. Okay. So that means probability that z is greater than this is plus 20, right? Plus 20 divided by 20 root 2. So 20 20 get cancelled. So it will be probability that z is greater than 1 by root 2. So 1 by root 2 is because root 2 is 1.1414. So 1 by root 2 is 0.707, right? So it is probability that z is greater than 0.707. And I think we have given the value for, okay, what is this? Okay, first of all, what is probability that z is greater than 0.707? 1 minus
1 minus fc of 7.
fg of 0.707, right? So this fg of 0.707, I think it is given to us. So this is the question. It is 0.76115. So 1 minus 0.66115, that should be the answer, and it is coming as 0.23885, right? You understand, right, how to solve this? Now if you
Yes, sir.
have some questions related to this, right, you will be able to solve this. We will move to the next question, which is, yeah. So here you have to use weak of large numbers. So question is, let x be a random variable having the gamma distribution with parameters alpha equal to n and beta equals to 1. Okay, and that property, you know, if x is gamma alpha beta, then expectation is alpha by beta and variance is alpha by beta square. So we have to find the value of n. Okay, n, that means value of alpha, such that probability that x by mod of x by n minus 1 is greater than 0.01, it should be less than 0.01. So you know a weak of large number, right?
Sigma square by delta square.
So yeah, so that is the probability that x by n minus, so that x minus n mu is greater than delta is what? Less than sigma square by n delta square, correct, right? So you have to use that thing to solve this problem.
Sir, if you are writing, we are unable to see, sir. That's
No, I'm not writing. I'm just telling. I'm not writing. Okay. So take 5 more minutes and try to solve it. Okay, one more minute and we'll discuss the solution. Okay.
But this same question is also in the graded assignment, sir. Right, sir?
I think similar will be there.
Similar.
Yeah, yeah. So most of the time, like solve with us is most of the questions will be similar to a grade assignments. So yeah, so that's what if you try to solve it here, you'll be able to solve the grade assignment properly. Okay, I think we should start see the solution now. Okay. 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 Given that x is having a distribution of gamma, alpha beta, which alpha is n and beta is 1, right? You have to find probability that mod of x by n minus 1 is greater than 0.01, which is less than 0.01. Now let x is x1 plus x2 to xn, where xi is gamma 1 comma 1. Okay. Why this? How we can write this x equals to x1 plus x2 to xn, and each xi equal to gamma 1 comma 1?
Because when we add these gamma 1 comma 1 n times, we will get
It will become n alpha comma beta, right? So here, because n is so we have given that x is
Actually, they given, sir, alpha is equal to
n and
alpha and beta. They given. Na?
Okay, okay, okay. So I will tell you once more. Like, so suppose x is given as what? Gamma n. This is given, right? Correct?
Yeah, yeah.
This is alpha equal to n and beta equals to 1.
Right, sir, right.
But we know that sum of n independent gamma alpha beta is what? it is having the distribution of gamma n alpha beta, right? This property we know, right?
Yes, sir.
So okay, if you don't remember, I'll show you the slides. Maybe, yeah. See, so this sum of n independent gamma alpha beta is what? Gamma n alpha beta, right? So this we know.
Right, sir. Right.
Okay. Now, in this case, if x is gamma n comma 1, right? So can I say that this x can be written as like this: y1 plus y2 up to yn, where each yi is what?
Gamma 1, comma 1.
Gamma 1 comma 1. Can I write this? So
Yes, sir.
that sum will become, this will become gamma n comma 1, right? Because n alpha n into 1 to beta 1, which is nothing but gamma n comma 1, right? We can write this like this, right?
I have a question. In the problem, alpha is given as n, isn't it?
Yeah. So alpha is given as 1, n.
No, n.
Beta,
Alpha is n and beta is 1.
1, right? So because, so can I write this x, this capital X as y1 plus y2 to yn?
Okay.
Okay.
Sum of.
And each y, let's assume that each yi is what? Okay, let's say, so each yi is gamma 1 comma 1. If I'm assuming this,
Yeah.
Yes, sir.
so sum of n gammas is what?
Yeah.
It is gamma
1, comma.
So n times 1 comma 1, right? N alpha beta.
Yeah.
So that's, I can write this as gamma n comma 1, which is given here, which is x. For understanding what I'm trying to do.
Yes, sir.
Yeah, you're writing x is a set of
Sum of
y IDDs.
Yes.
Of n in dimension, and each y being gamma of 1 comma 1, and that summation is giving gamma n comma 1.
Correct.
Yeah.
So if I wanted to find probability that what, okay, now what we have to find is, so this is clear, right? What we are trying to do. 1 minute. No, see, so until this point is clear, correct? So this here it is written as x equal to x1 plus x2 to xn. So I was showing you because that y and x should not get confused. So this is same thing as x equal to y1 plus y2 to yn, and each xi is gamma 1 comma 1. Now I know that x1, the sum of this is gamma n comma 1. Actually, it's not n alpha beta, it's n comma 1. Okay, fine. So what is expectation of each xi here? It is 1 by 1, right? Alpha by beta, because each xi here or each yi here is what? Gamma 1 comma 1. So here expectation of each xi or each yi is 1 upon 1 is equal to 1, and variance of each xi is 1 upon 1 square, which is again 1. This is okay?
Yes, sir.
Now what we have to find is probability that mod of x by n minus 1 is greater than 0.01 is less than 0.01. Now I
why?
already wrote.
One question: why are we writing it as variance of x when we already converted? Okay, because x is assumed to be a summation of y's.
Correct, right?
Okay.
Now this is y1 plus y2. Consider this as y1 plus y2 like this. Okay, if you are getting confused with that x and x1, so this is y1 plus y2 until yn divided by n minus 1. So I know that expectation of all this x1 plus x2 to xn divided by n is what? N times 1 divided by n, right? So that means n by n equal to 1. That is okay, right?
Okay, you're substituting x as summation of xi to xn, is it? Okay.
Correct, right? Now
Yeah.
this problem is similar to what? Probability that x by n minus mu, right, greater than delta is less than sigma square by n delta square. This line.
This is from weak law of large numbers. Okay.
Weak law of large number. So what is weak law of large number? Mod of x minus n mu is greater than 0.01. So greater than delta is less than sigma square by n delta square, right? Okay. This is understandable, right?
Yeah, sir. Right.
Okay. So I know that, so I can compare this one, right? This equation, the first one and the second one. So this 0.01 will be equal to what? Sigma square upon n delta square. So delta here is 0.01. So sigma square by, we don't know n, sigma square by n 0.01 square is equal to what? 0.01. Now I know sigma square is what? 1 again. So let's say I will try this probability that x by n minus, actually it should be here mu, right? So mu is equal to 1 now. We showed that, right? Is greater than some delta. Delta is 0.01. This is delta. This is mu. This one is mu. Okay, is less than sigma square upon n delta square. But we have given in the problem this line is greater than 0.01 is less than 0.01. So this is equation 1. This is equation 2. Comparing these two equation by using weak law of large numbers, I can say that sigma square upon n delta square is equal to what? 0.01, right? And I know that what is sigma square now? It's 1. N I don't know. Delta is here. 0.01 is square equal to 0.01. Now then this n will go to that right side, so it will become 1 upon 0.01 cube, right, equal to n. If I say that, n become equal to 1 upon 10 to the power minus 2 to the power 3, right? It's 1 upon 10 to the power minus 6, which is n equal to 10 to the power 6. So that should be the correct answer.
Yes, sir.
Okay. Okay. So we'll move to the next slide. This is again similar kind of question, but here what we have to use is we have to use CLT instead of weak law of large number to find n. So let x be a random variable having the gamma distribution with parameters alpha equal to n and beta equals to 1. If x is gamma alpha comma beta, okay, that information you know now. Now we have to find the value of n such that probability that mod of x by n minus 1 greater than 0.01 is less than 0.01. So you have to convert this problem into the CLT problem, and you have to find the value of n here. So take some time and try to solve this.
Sir, it's similar to the last problem. I didn't find any difference.
So there will be yeah. So the all the procedure towards left side will be same, right? But the difference is you had that sigma square by n delta square right there, less than this one. But here you don't know. You have to first convert this x by n minus 1 to z. So your problem will become like this somewhat. It will look like this.
Right, sir. Understood. Understood.
Right, no? So it should look like this. Probability that mod of z should be greater than some delta, right? Is less than 0.0. It's given here. So you have to convert this to this form. And we know that mod of z is greater than delta is 2 times probability that z, right? Z is greater than delta, something like this. Then you have to solve this equation.
So, can you show the question 3 calculations for seconds?
For
the previous question, the calculation that you have done, the final calculation. I just want to make a note.
Okay.
The next one, sir, after when you are computing the use WLN, 1 by 10 power minus 6, that step. So,
oh, okay. The written one, huh?
Yeah.
Yeah. So should I do it again? So if it is not properly.
Which is no, just for a second, I have to make a note of it.
So maybe if this is somewhat messy, let's say I will try to do it here again. Okay. So this is clear, right? This step 1 upon n into delta square equal to 0.01. This n will go to this side and that 0.01 will go to the denominator. Then n will become 1 upon 0.01. So this 0.01 I can write it as 10 to the power minus 2, right? And and this cube. So we know by this property it will multiply. So this will become 1 upon 10 to the power minus 6 equal to n. Now taking to here, so n equal to, and if you come to the, so the 10 to the power minus 6, right? It's in denominator. So when it comes to the numerator, it will become 10 to the power 6.
Yes, sir, thank you.
Okay.
So I think I'm asking a basic question, but in the earlier slides, earlier question slides, the expectation of x1 plus up to plus xn divided by n, why did we consider it as equal to 1? I didn't understand that part.
Okay, this one, huh?
Yeah.
So you know each x1 is what? Gamma 1, comma 1, right?
Oh, that's why. Okay.
So expectation of x1 is what? 1, right?
Okay.
Times 1 divided by
Oh, I see.
n.
I got it now. I totally missed that part. Thanks.
Okay, that's okay.
Just a question here. Hello.
Okay, I was reading the chat in between. So yeah, somebody's asked like Z values are given will be given in the exams or not. Yeah, so FZ values are given in the exam. So you have to, but yeah, so there will be like 4 5 values will be given, and you have to select the appropriate one that is there. So it will be a common data available, and you have to pick one of the values from there, right? Okay. So how many responses? Okay, 7 responses out of 37. Others, please try to solve the question. So it's like similar one which we have solved for question 1 and 2. It's very similar to that.
In this question, two options should be correct. Two and three. So
Both the options are correct.
yes, sir.
Why?
Yes, sir. Two options are correct.
66, 5, 64.
Okay.
And should be greater than 10 should be greater than 63, 5, 64. There
Okay.
are two options greater than.
Okay. 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 Fine. Fine. Okay. We'll see. We'll see. So, so shall we see the solution now?
Yes.
Okay. So yeah, see this is the setup. We wanted to find probability that mod of x by n minus n is greater than, so not n actually. Okay, I think it's 1, right? So yeah, so 1 greater than 0.01 is less than 0.01, right? Now probability that x1 plus dash 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 plus xn divided by n minus 1. So you know, you understand this step, right? The second one, because we know that x is gamma n comma beta. We have converted that n comma beta into sum of n independent IID random variables, right? So it will become x1 plus x2 to xn. So you can say it's at y1 plus y2 to yn also, right? Divided by n minus 1 greater than 0.01 is less than 0.01. Now, so I can actually shift this n to here, right? So it will become, okay, this step maybe I'll try to write it. So this was like this, right? So this is x1 plus x2 to xn divided by, oh sorry, I think divided by n minus 1, and I think it's greater than 0.01, and this entire thing is less than 0.01. Okay, so this n, right? So you can make a so this n become common denominator. How that can be done? So it will be x1 plus x2 up to xn minus n, right? Divided by n greater than 0.01 less than 0.01. Now probability that, so this numerator will be as it is. So can I write this n into two parts, like root n into root n? I can write, right?
Yes, sir, obviously.
So one root n I'm sending here, and I'm keeping one root n here. So this will become 0.01 times root n, and it's less than 0.01. Okay, this is this third step. Probability that mod of x1 plus x2 to xn minus n divided by root n greater than 0.01 into root n less than 0.01. Now this is what? Because this is y minus n mu upon sigma root n. Is it not like that? It's like that, right?
Sir, yes,
Because
sir.
mu is 1
Sir,
here.
sigma is root n, right?
So no, sigma is what? 1, right? If you recall this thing. So sigma square is 1, right?
Sir.
So okay. Maybe I'll try to write it. Okay. So because we know that this, what is our central limit theorem? Consider this as y. Huh? So what is our central limit theorem? Y minus n mu divided by sigma root n, right? Hmm?
Yes, sir.
So
Yes.
if this sum is y, so minus n into what? Mu is what? 1, right? Because all are gamma 1
1
comma 1.
comma 1.
Huh. So and what then for that mu is 1 and sigma square is also 1, and which ultimately becomes sigma equal to also 1.
1.
So 1 into root n. So this will become y minus n divided by root n. And this is what? My z, right? Z, normal z1. So okay, this is mod z. Now this is z. Okay, fine, right? This is fine, right? x1 plus x2 to xn minus n divided by root n. This is z, correct?
Yes, sir.
Okay, so mod of z is greater than 0.01 into root n less than 0.01. And I already told you this mod of z means what? 2 times, right? You understand this concept, right? Mod of z is equals to some a, and it is equals to 2 times. So that
Yes, yes, sir. Because
modulus operator, you know, right? So
yes, sir. Yes.
similar thing. And so plus, so whatever things remaining to that greater than alpha.
So sorry,
And
could
less
you repeat
than
that 2p steps? Sorry, how is it?
which one? This one, huh? Mod
2p,
z.
2p, the next
Okay,
one.
fine. So maybe I'll try to write. So we will try to see by using this curve. So this is normal z1 curve, correct? Hmm? And this is 0. This is normal 0 1 curve. Now if I want, so my z equals to, let's say, so mod of z is some, let's say, some uh, alpha is there. Okay, what does that mean? Or not equal to is, I'll say greater than. Mod of z is greater than alpha. Okay,
Z is beyond minus alpha to
so
alpha.
that means z is greater than alpha, huh? And
Less than minus alpha.
or um, or z is
Less than minus alpha.
minus alpha. Is it okay? Is it okay? This thing is clear.
Yes, sir.
Yes, yes, yes.
So what is this? Z is greater than alpha means which part? So let's say alpha is here. That means the right side of this, right?
Yes, sir.
This probability, correct? Z greater than alpha. So whatever things are there greater than alpha, this side probability, and Z less than minus alpha. So minus alpha will be here somewhere, right? And Z less than minus alpha means which side, which area?
Left
All the
side.
area towards left side. So and we know this is symmetric, right? So this portion or this area is equal to what? This area, because this is from minus infinity to minus alpha, and this from alpha to plus
Infinity.
infinity, right?
Yes, sir.
So these both areas are same. So that means what? I can write
Two
what is
times f.
probability that
2 times f of minus.
okay, yeah, so that I can directly write this also, right? Fz of minus alpha also. Is this okay? Because fz of minus alpha means which portion? This portion, correct? and I'm just, because since this portion and this portion is same, so I can write 2 times fz of minus alpha, or else I can write what, 2 times
fz of alpha.
no, sorry, not 1 minus 1 minus fz of alpha. Can I write this? So
Yes,
what
sir.
is fz of alpha?
1 minus f of minus f.
So that means which area? This entire area, right?
Yes, sir.
This is fz of alpha. The blue color is fz of alpha. And what is 1 minus fz of alpha? That
Only the right portion above, like beyond alpha. Yeah.
so I can write, so this is same, and this yellow portion and this portion is same. So I can write 2 times 1 minus fz of alpha. So either you can write 2 times fz of minus alpha, or you can write 2 times 1 minus fz of alpha, whichever you are comfortable. Or
So how can it be 1 minus fz, 2 times fz of alpha?
see what is
Both
it?
are different, no?
No, both are same. See, okay, I'll try to, okay, one more time I will try to
We are cutting on both sides, sir.
No.
see. Okay, we'll try.
No, before that one, the mod of z
mod of z is greater than alpha.
less than alpha, right? Mod of z. Now, can we really write it independently? Z is greater than alpha, and plus z is greater than alpha, minus z is greater, or minus z is greater than alpha.
What is the meaning of mod of modulus of something? That means,
yeah, now we are just opening it out, and the plus or minus z alpha, no?
No, even if you take it as minus z greater than alpha, you multiply by minus all sides. It will convert to z. Z is less than.
Let's step through that one. Yeah,
okay,
it's obvious, but let's step through that.
Okay, this is okay,
So
right?
then z is minus alpha, no?
Z is, but then this sign also will change, no?
Yes.
Minus
Z
alpha.
is less than minus alpha or alpha.
So I can write.
So that is where the confusion is. Z is, when we are changing the sign, the minus sign also will be there.
Okay. So first of all, you understand this part, right? Okay, we'll go by step only.
Yeah.
Let's say mod of z is greater than alpha. What does that mean? Either z is greater than alpha, or
yes,
minus z is,
or z is minus z is greater than alpha.
So z is greater than alpha, or so if I wanted to change, because I have all the values in terms of z only, not in terms of minus z, right?
Yeah.
So I have to change the sign of this. So what I have to do, I have to
multiply both the sides minus, no?
Minus. So this becomes z. But when
Z.
we are doing that, right, that greater than sign will also change to.
Yeah, that is the question I was asking. When we are doing that one,
yeah, that will
we changing the inequality is also changing, and the sign
yes.
of the alpha is also
Actually,
changing.
if you try to see by like, if you try to visualize it, right, it is very easy. If you try to go by math, so mathematically that sign will change. But what does that mean? What is the interpretation of it is, because okay, you know this xy axis, right?
Yeah.
This part, now
right.
I wanted to say that let's say mod of minus 2 is, let's say something 3. Oh, sorry, not mod of minus 2. So let's say
put x.
My mod of something, mod of x, let's say.
Mod of 2 is x. Okay, either way.
Something like that. Okay. What does that mean?
Okay.
What is the interpretation of
x is equal to 3 minus x is equal to 3.
X equal to 3 and minus x equal to, so and so if I say y is equal to mod of x, what that means, y value will always be positive irrespective of values of x.
Yes.
So
there's 3.
So let's say it is so y value is something like that. So let's say some values there.
3
I'm taking. So whenever my x equal to what?
3 or
so when my x equal to 3, then my y value will also be equal to positive 3. And when my x equal to minus 3 is also
Plus 3. Okay.
So what does that mean? So that
What does
change
it mean?
sign, right? Okay, okay. Still, okay, I don't think I'm not able to convey the same thing here. Okay.
Please check my mod x is greater than 3 itself. I think we really
Yeah,
got
I
that.
think that will be really right. So yeah, let's
I
say
think we are
mod x is greater than 3. What does that mean? So
mod
that means
x is greater than 3. Plus x is greater than 3. Minus x is greater than 3.
so is it minus x is greater than 3 then?
Mathematically, that's what we just step through. Then we have to really interpret that.
Okay. Let's keep that part. Okay. Okay, I'll try to at the end I'll try to somehow figure it out, like how to explain this one. But
All
for now,
right.
okay, uh,
For now, I'll take it that
we
way.
can we can understand it by graph
yeah,
because
yeah.
mod x
Actually,
is symmetric about y axis. So
uh, uh, yeah. So that but okay. Let's say what I'm saying is mathematically, if you are saying this, right, it's z is greater than alpha and minus z is greater than alpha. This step is clear for you, right? Now, when I
yes, sir.
wanted to change the sign of this, the sign of this equality will also change. So it will become z is less than minus alpha.
Okay, for now, I will take it. Inequality also will change and the sign is also
It
minus.
changes,
Okay.
right? So now z is greater than alpha means which part of the probability, which part of this? So this part, because this is alpha, right? And minus alpha is what? Here. So z is less than minus alpha is which part of this curve?
Left side.
This curve,
Left. Yeah.
left side of this curve. But since it is symmetric, we know that this part, this left side part and the right side shaded part, both are equal.
Equal.
So I can write, and what is the definition of f0 of minus alpha? This part, right? This area,
Yes.
the left side area.
Let's put
So
it x.
okay, so whatever. So let's say f0 minus of alpha is this part, huh? So and this part is also same as that of this, right? So I can write
Yes.
2 times f0 of alpha. One more way of doing this is, what is f0 of alpha? Which part? Which area? So this entire area from minus infinity to until this alpha, right?
Yes, sir.
But we are interested in the right portion of alpha, correct? This is we are interested in. So how to
Yes.
find this area?
1 minus fg of
1 minus f0 of alpha, and this area, the red the circled area is similar to what? This area, correct?
yes, sir.
1 minus 2 fz of alpha.
Into 2, both are same. So either you can write 2 times f0 of minus alpha, or you can write 2 into 1 minus f0 of alpha. Both are similar. Okay, I think it's clear, right? Okay, if you are not clear, once again go through that. Maybe if you see, it will become clear. Okay, so same thing here. So this is 2 times probability that z is greater than this portion, right? So this is nothing but 1 minus fz of 0.00, sorry, not 0.0, not 1 minus fz of 0.01 root 10. This is 2 times 2 times 1 minus fz of this. So that 2 goes to this side, right hand side. So 0.01 by 2. You understand this step? Okay.
Yes, sir.
So there something is there. So you understand this, right? At least. So I can write this as, sorry, 2 times fz of alpha. I can write this, right? So not 1 minus fz of alpha, right? Or I can write 2 times fz of minus alpha. So here, what is alpha here? It's 0.01 n, right? Root n is my alpha, right? In this case. So if I wanted to write in this term, so 2 times 1 minus fz of 0.01 root n is, it's less than, I think, 0.01. This is my inequality, right? So this become 1 minus fz of 0.01 root n, and this 2 will go to that side. It will become 0.01 by 2. Now this is 1 minus fz of 0.01 root n less than is 0.005, correct? And that this term can come to left hand side, so it will become 1 minus 0.005 less than fz of 0.01 root n, and this becomes 0. How much? I think it's 995 of fz of 0.01 0.01 or 0 okay 0.01 root n. Okay, so these are the steps until here. So fz of 0.01 n root n is greater than 0.995, which is same, right? Here it is written this way: 0.995 is less than our fz of 0.01 root n. Same thing here, it's written here. Now fz of 0.01.
So there is a confusion in fact. If you take the right side and left side kind of thing, that will be that will not be the same thing what we have taken in the notes. I mean, you are written there.
Same, right? Can I write this? Okay. If I wanted to write fz this side, let's say fz of 0.01 root n is what? I can write greater, na? See, this and this is same, right?
Right, sir. Thank you.
Okay. So this is okay. This is written here like this. So 0.0 n root n is greater than 995. One more thing is given here. So 0.995 is what? fz of 2.58.
2.58.
Okay. So fz of this side I'm keeping as it is. That 0.995 I'm replacing with fz of 2.58. Now I can compare these two, right? So these values are should be equal, right? So
Yes,
I
sir.
can, or I can take the fz inverse on both sides. It will become 0.01 root n greater than 2.58. Now this root n is there, so I'll do the square. Or first of all, like what I can do is, yeah, this step I'll write maybe.
You show the question for a minute, sir. Just one minute.
Okay. Question or answer? This one.
Questions are first one, first one. Yeah, this one. Just a second.
Correct answer is not in the option.
No, that's what they said. No, 2 and 3. We'll come to that. We'll come to that point. First of all, understand this part.
Option 2 is the right answer.
2 and 3 both. So see, this 0.01 root n is greater than what? 2.58. Now this 0.01 come to the denominator side. So root n greater than 2.58 divided by 0.01. So root n becomes, so this is 100, right? 10 to the power minus 2. It will go to numerator, it will become 100. So 2.58 into 100 is 258. And both, so I wanted n value of n. So I'll be doing squaring on both sides. This becomes n greater than 258 square. So n is greater than that, some values there, right? So this is 66564, right? And whichever value greater than 66564 is the right answer. So here two values are there which are greater than 66564. Option 2 and option 3.
2 and 3, yeah?
Yeah, both are correct. Okay. Okay, so we'll move to the next question.
Sir, I have a small doubt here, sir. Sir, why do we take this x to be consisting of sir, n random variables?
Because see, because if we have given capital X as gamma, what, n alpha comma beta, right? So or n comma 1, but we don't know. So if with that information, if you wanted to find out the mean value of that, right, how we are going to find it? So that's why we are converted into this. So and it's not needed actually to convert into this x1 plus x2 to xn also. You can actually directly use that gamma n comma 1 and you can solve it. But how you are going to solve it, you know that, right?
Okay, sir.
So you can actually solve it, it's not a problem. But to understand better, you can actually convert it into this x1 plus x2 to n. Otherwise fine, x minus that x, right, gamma n comma 1 is there. You can actually solve it because you have to convert that x into the central limit theorem. That's it. Okay.
Thank you, sir.
So this is, yeah, so this is fifth question. Is suppose speed of vehicles on a particular.
Can I interrupt 1 second, please? How you actually use the inequality to establish the correct answer? So any problem, even in the previous weeks, there were a couple of problems wherein the inequality would come and the answer would be 108.9. Then we either round up or round down, is it?
So it depends on that inequality. So in this case, we have n is greater than 66564. What does that mean? That means n value should be greater
Greater
than.
than, correct.
So it if in the option, right, if 66564 is also there, right, it is incorrect answer, because this what this inequality says, it's not greater than or equal to, it is strictly greater than. So that means 66564 is also a wrong answer. Your value should be 66565. It should start from that point. So whatever values will be there, it will be like that. If this, in this case, if let's say n is less than 66564, that means what is the correct answer? Any value which is less than 564, but not 66564 in that case also, right? But if that inequality is n is greater than or equal to 66564, that means, and if I ask what is the minimum value in that, then which is the minimum value? N is greater. Okay, we'll see some of the problems.
Then should I take any value less than? Okay, it will be any value.
I'll say, let's say n is greater than 20, and I ask find the minimum value of n.
21.
What is minimum value of n in this case?
21.
21, right? Correct?
Yeah.
Let's say n is less than 20. What is the minimum value? So not minimum in this case.
Maximum
What is
is
the maximum
19.
value of n?
19.
Maximum value is 19.
Yeah.
In this case, n is greater than or equal to 20. What is the minimum value of n?
20.
20. And n is less than or equal to 20. What is the maximum value?
20.
Yeah, that is.
Okay, got it. Thank you.
So when in the question, right? So maybe in the exam papers also, maybe in Chebyshev inequality or somewhere, I don't know. They will be asking what is the minimum value of this. So might be your answer comes as like this, right? 1.08 or something. And they will be asking you to find the next highest integer or something that way. In that case, it should be 2, right?
Okay, got it.
Also in one of the activity questions, answer would be coming 618.7 maybe. Then the correct answer was 619.
Because the next highest integer, right? So next highest integer should be more than the 61, because you can't write 618, right, in this case, because it should be highest. The more than already 618.7 is greater than 618, so you can't write 618 there. The value should be more than 618.7, and if it is integer, in that case it is 619, so it should be rounded up there, that point. Okay. This is fifth question. This one is, suppose speed of vehicles on a particular road are normally distributed with mean 25 and standard deviation of 3 mph. Find the probability that the mean speed of 30 randomly selected vehicles is between 24 and 27 mph. So here, first of all, tell me what is x bar here?
$25.
No.
So it's not, mu is 25.
That mu is 25 and standard
Sample
deviation
mean.
3 is a population standard deviation, population mean, right? and this x bar is a sample mean, right?
Yeah, sir. Yeah.
So so x bar is what? Sample mean of what? 30?
30 randomly select.
30
Yeah.
randomly
30 to 25. Right.
So it should be x1. So what I wanted in terms of x1 x2? How can I write
x1 plus up to plus x30 divided by 30.
30, right?
Yeah.
Okay, and that mean equal to 25 and standard deviation equal to 3 is the distribution mean and distribution standard deviation. So this problem will look like this. So this problem will look like this, something like this. So my x1 x2 to x30 is IID x. So IID x is what? Is IID normal 25 9, right? This mu equal to 25 and sigma square equal to 9. So this is like this, and this x bar is what? Sample mean, right? Is x1 plus x2 to x30 divided by 30. Now what is the question? So this mean speed should be in between 25 to, so what basically you have to find is probability that 27 is great. How much it is?
30.
Okay, so 24 to 27. Sorry.
So when it is between, it should be less than or equal to, or we can always keep less than, like just
So between will always be this strictly
less than. Okay.
strictly less than. It should not be, because between, right? It won't include those values actually.
Okay. Yeah.
So the first one is x1, x2, x2. The population is up to x30 and sample is also x30.
No. Population is different. So population means each xi, right? Each sample.
Yeah, but you put as x30, no?
Is coming from that normal distribution.
Yeah, that's okay. But what is the, in your first line, what is it you're telling?
This one.
Yeah.
So this each x1, x2, x3, 30, right? All are identically distributed samples with having.
What is the sample size? What is the sample size? 30, is it?
Yeah, 30, no?
And the population size?
Population size, how will know?
Yeah. No, my question is because no, 25 and 3 are related to population, no?
Related to population, correct.
And the other one is related to the sample, 30 samples. So
Which is
my
other
question is, can we put 30 in either way, both the places? Can you go to your working sheet? Working sheet.
This one only, right?
No, this sheet. So this I am okay. The second line I am okay. The first line I am just getting confused. Should it be x30 there, or just leave it open, or x?
Oh, okay. You are saying about this, huh? This is nothing. This is nothing. I just this is not a bracket or something. It's just the representation of this samples, right? So generally, you know, right? This question will be like this. So you have such kind of questions, right? X1, x2 until x100 is IID something, let's say exponential 2, right? And find probability that x1 plus x2 up to x100 greater than 90 by using the exponential distribution or something, by using CLT or something, right? This is a way of representation, na? So this is what I'm saying is the speed of vehicles. So we have 30 vehicles. So the speed of vehicles. So the speed of each vehicle is represented by x1, x2, like that x30, and all are IID samples with distribution normal with normal distribution having n equals to 25 and sigma square equal to 9. So that
Okay.
can take actually any value.
So here we can, sir, just a query. Here we can extrapolate the distributions, sigma squared and then to the sample itself, right?
Sorry?
The 25, sorry, the mean and variance. That we can apply to the sample itself, right? From the question given here.
Okay, so just let, okay, I'll try to simplify one more.
Okay. No, like the question was just we can apply
You can
for
actually
30
apply.
samples.
Yeah, you
Yeah,
can
30.
apply actually. So
Okay.
x bar is this, right? x1 to x2 until x30 by 30. This is my x bar. So if I wanted expectation of x bar, how will I find? How will I find?
EF x1, EF x2.
We will find like this, right? Expectation of x1 plus expectation of
x1,
x2
x2, x3.
Until x30 divided by 30.
30.
So this is what? N times means like 30 times expectation of x1, right? Divided by 30. So expectation of x1 is what?
Not given IID.
25.
Yes,
25.
Right, because this is each xi is IID normal with 25 and 9. So expectation of x bar is also same as that of expectation of or mu in this case from here distribution mean. So expectation of a
Sir,
sample.
in the question IID is not given, no, so we are assuming IID, is it?
Yeah, it should be. It should assume like you should assume like this. This is a like practical concept related question. So this practical question, right? So you should assume that the speed of each vehicle it should be independent of each other, and then how? So here also it's not given like with which formula you have to solve this. You have to solve this by using the central limit theorem. Anyway, all are normal samples only.
Please show the answer, sir.
Just wait for I think 1 or 2 minutes. If someone is trying to solve, or is it done? Because I'm getting only 5 answers here.
I have a question here. This mu, when you normally see the average is 25, but the range is 24 and 27. This it is no longer symmetric. The delta, I mean, it is 1 on one side and 2 on the other side.
Yes. So how will you find?
Okay, that is the catch. Okay.
Yeah, that is. Try to use the normal, like whatever we are using until now, right? Same thing. Try to do that. Central limit theorem it applies here. So what we do in central limit theorem is we try to subtract the mean and divide by standard deviation, right? Here what happens? Here two different sides are there, but same procedure you have to apply. So 24 minus mu divided by sigma. That side also 27 minus mu upon sigma. So whatever values will come, we'll try to see how we are going to find the answer there. Okay.
That side it will be 27.
Basically, we are finding out P is mod of no longer mod actually.
Not mod here.
It's basically.
So 24 minus 25.
Greater than 1 is greater than 1 and other is greater than 2, is it?
Yes. So okay, I'll give you a hint here. Okay, how to visualize this one, right? So okay, still if you do this calculations, it will become a central limit theorem, right? So that automatically convert into that normal z1. Sorry, normal 0 1, right? So now the question here is, it should be in between alpha and beta. I'm saying that some alpha is here, and some beta is here. So I wanted to find which area.
In between.
Yeah.
Right. So what should be my approach?
Yeah.
Do a CDF till alpha and then subtract CDF of beta.
Yes. So first of all, because you know fz of alpha. This is this area, red portion area, right? And then what is
Subtract
fz
the
of
of
beta?
beta.
Beta and minus subject of beta.
Right. So if I subtract fz of alpha minus fz of beta, I'll get the desired area. So which is this one, right? The middle portion. That is the only thing you have to do. Okay. We'll see the solution now. Okay. So each x1 to x30 is IID x belongs to x, right? And x, we know that it's normally distributed with mu equals 25 and sigma equal to 3. Now 24 is less than x bar less than 27, right? Now probability is that this thing x bar is what, x1 plus x2 to x30 by 30. So I'm converting this. I'm saying that x1 plus x30 as y, a random variable y. So 24 is less than y by 30 less than 27. Now what is mu here? 25, right? So this minus mu. So both side I subtracted mean. So it will become minus 1 is less than y minus 25, y by 30 minus 25. So eventually it becomes this 30 will go to that side, right? The numerator. So y minus 25 into 30 by 30 is between minus 1 and 2. Now this 30 I can convert it into two parts. So root 30 into root 30. Fine. And that root 30 will go to this side. Okay, I will try to show this how it comes. So I'm assuming that you guys understand this part.
And in that particular step, 1 by 3 is also there, sir. How it is coming 1 by 3, sir? All the left, middle, and right.
Yeah, I will show you. So 24 minus 25 less than y by 30 minus 25 less than 27 minus 25. This is fine. This part is fine. Okay.
First we have to multiply by 30, na?
You can do that way also, or you can, like, it's fine only, right? So first of all I'm saying this is okay. Go through like this. This is okay. This is okay or not? First of all.
Okay.
Okay, sir.
Yeah.
Okay.
Come minus 1. Minus 1 is less than y minus 25 into 30 divided by 30. This becomes 2. Now, because see, what is my z? Z should be like this, right? Y minus n mu upon root n into sigma. This is z, right? What I'm trying to do is I'm trying to convert that y by 30 into this term. So this y by 30, right? I'm trying to convert it into this term. So for that, what I need here is root n in the denominator. In the numerator, it's n into mu, right? This is n into mu. So numerator is satisfied, but denominator, I don't want n. I wanted root n. So what I do is, so I'll do minus 25 into 30 divided by root 30 into root 30. Okay, less than 2. So this root 30 can go to the both sides. So this will become into root 30 into root 30. So in the next step,
Added
will become
division by
minus 30 y minus 25 into 30 divided by root 30 into 2 into root 30, right? Now, what else I need to convert into z? I have
division
to
of
divide it by sigma. So what I'll do, I'll divide it by all sides. So it will become probability. And what is sigma here?
3.
3. So I'm dividing it 30 by 3.
So
Then
it will be minus root 30 by 3.
sorry, yeah, minus root 30 by 3. And here it will become 2 into root 30 by 3. Okay, right?
yes, sir.
Yeah. So this is there. So this step. So we come to this step now. This
So I'm
y
dividing the entire thing by 3 because of the standard deviation, is it?
because of the standard deviation, because we wanted
Okay.
the term into that our format, right? Y minus n.
Okay.
Sigma. So this term this middle term becomes z. So probability that minus root 30 by 3 is less than z is less than 2 into root 30 by 3. So that minus root. So I told you, right? So this is nothing but that fz of alpha. So let's say this is beta, right? This is beta and this is alpha. This becomes fz of alpha minus fz of beta, right? This thing, have you understand this thing? The last one?
Yes, sir. Yes, sir.
Okay.
So basically 3.
Understood how it came 3.65, sir.
Okay. So I'll show that also. Okay. So this is okay. Until this point, it's fine, right? This probability that minus, I think, root 30 by 3 is less than z less than 2 root 30 by 3. This
Yes,
term
I have understood till here.
now. So what is this? What is this value? If you calculate, can you calculate this? Root 30 by 3. Somebody please tell me what is the value of this?
1.825.
Minus 1.825. And what is this value? 2 into root 30 by 2.
3.651.
3.6515.
3.65. Okay, I'll say only 3.65. What I told you before is okay. So this normal, since this is z, right? This is z01. Okay.
Yes, sir.
So where my 3.65 will lie? This side, right side, right?
Yeah.
Somewhere here.
Yes, sir.
Let's say it's 3.65 is somewhere here. Where this
Yeah.
value will come? Minus 1.
On the left side.
Left side somewhere very so closer to this, right?
Yes, sir.
These are not equal. Minus 1.825. Okay. What is fz of 3.65?
Entire left side area, sir.
Yeah.
Okay.
Entire
1
left side
minus.
So
area.
this
Just the left side area, complete
Yeah.
left side area. Yes.
and I wanted fz to be
In
less than
between.
3.65. So yeah, but now let's say fz is f of 3.65 is somewhere here. Fz of 3.65 is there. And what is minus 1.825? Where? This area.
Yes.
Right.
Extreme left, yes.
So what I have to do basically to find the area between minus 1.825 and 3.65. So this is
FZ
my
of
area of interest, right?
3.6. Yes,
This
yes.
is
FZ of
my
3.65 minus.
So this is actually, I think you guys know that, right? probability that A is between, let's say, Z and B is nothing but f of B minus f of A from
Yes.
CDF.
Yes,
CDF.
yes.
Yes, sir.
It was there in week 4.
So this is A, this is B. I'm just doing fz of B, which is 3.65 minus fz of A, which is minus 1.82.
825.
So if I, because I know fz of 3.65 is the entire area towards my, so towards left side towards my 3.65, and fz of minus 1.25 is this area left of this red color portion. But I'm interested in what, between, in between area of these two values. So I have to subtract this red portion from the entire blue portion, then I'll get this value. Correct? Understood, right?
Yes, sir.
Okay.
So the answer sheet is that area is given.
No, no, it's not good. It's like fz of
The solution sheet is, what's it having? Root 30.3.
this this thing.
3.65 minus. Okay, it's in terms of Z.
fz. Okay, right. Okay, this is the last question. So what is the fourth moment of the normal 0-9 distribution? So this is related to MGF. You know that MGF of normal distribution. Do you know MGF of normal distribution? It's e to the power
Oh,
It is about sigma square lambda square by 2.
lambda square by 2. So MGF of normal distribution is expected value of e to the power, no, not expected value. So expected value of e to the power lambda x, where x is a normal distribution, is equal to e to the power lambda square sigma square by 2. I'll write it down here. So let's say x is my normal distribution. Okay, then MGF of x is expected value of lambda x, right, which is e to the power sigma square lambda square by 2. So you have to use this. So take like 2-3 minutes and we'll finish it off. Like I'll show the solution. I don't know like all of you will be able to solve this or not. We'll try to see. So okay, one more hint is you know the expansion of exponential distribution, right? So you have to use that one. So what is expansion of e to the power lambda x? So e to the power x.
X plus x1 by factorial 1 plus x by factorial 2, x square factorial 2 plus x square factorial 2.
Correct. So that thing you have to use here.
Yes, sir. Answer is 243.
Yeah, right into that thing, right? That joinpd.com. We'll see. Okay, I think we should see the solution and finish up the session now. Huh? Okay. So what is fourth moment first of all? In the moment generating function, coefficient of lambda, okay, the coefficient of lambda gives first moment. Hmm? Coefficient of lambda square by 2 factorial will give you the second moment, which is expectation of x square, and coefficient of lambda to the power k divided by k factorial will give you the kth moment. Hmm? Now we'll see. Okay, I'll write it down maybe because this is. Hmm. So what is the, let's say x is my what, normal, what is this, can you tell me, 03 or something there, huh?
09.
09, okay, 09. Hmm? So mgf of this variable
03 square.
okay, so it is expectation of what is this expectation of e to the power lambda x. So I told you, can you tell me what is the expansion of e to the power x?
1 plus
1 plus
x by
e
factorial
power
1,
lambda
x by factorial 1
Hmm.
plus x square by factorial 2 plus x cube by factorial 3 and so on.
Right.
x4
Okay, can you tell me the expansion of e to the power lambda x?
1 plus
So
e power
expansion
lambda
inside
x.
1
yeah,
plus
lambda x by 1
hmm?
lambda square x square by 2 lambda cube x cube by 3 into 2 is 6
So maybe I can write, okay, 3 factorial.
factorial 3, you can write factorial 3, yes, lambda 4 x4 by
4
factorial.
so on. So you okay, if I use that expectation inside, so it will be expectation of 1, so it will become again 1 because its expectation of a constant is constant, right? So 1 plus what is this,
Lambda into expectation of x,
right, then
lambda square into expectation of x square, yes, factorial.
is okay.
Yes, okay, lambda cube by factorial 3
1 minute, just
no problem,
so here lambda cube by
factorial 3
the expectation of
x cube
plus
lambda 4 by factorial 4
expectation of
x4,
4 and like that.
yes.
Now what is the e to the power lambda square sigma square by 2, right? I know that expectation of e to the power sorry, e to the power lambda x is e to the power lambda square sigma square by 2 for normal distribution, right? So and what is sigma here, sigma square here?
9.
9.
So can I replace here, it's 9
3 square.
so it will be 9 by e to the power lambda square 9 by 2, huh? So what is the expansion of this term?
So now 1 plus 1 plus then lambda square lambda
So 1 minute,
Lambda by 1
yes
into e power
lambda
3
square 9 by 2.
yes 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 yes
Plus then lambda square 9 by 2 square divided by
correct
2 factorial plus lambda cube 9 by 2 cube, sorry this is sorry, this is lambda square 9 by 2 cube divided by 3 factorial, is it like that?
yes yes
And so on. So if I expand this, it should become 1 plus 9 by 2 lambda square plus this what, 9 square is what,
81
81
81 by
2
4
square is 4 into 2 factorial into lambda to the power 4. Okay,
correct
lambda
correct yes
square
sir correct
by 2 is right. So it is like lambda raised to 4, 81 by
by 4
4.
into factorial.
This is
Correct.
9 divided by
Yes, the second factor is lambda square 9 divided by 2 or 1.
divided by 2. See, this is term, right? So we know, I know that e to the power x is
Okay.
right. So this
Okay.
entire term is x.
No. Okay. You got. You should have written that lambda square 9 divided by 2 whole divided by 1 because that
Okay.
will be similar to the other factors.
Okay, I can write like this.
Yeah.
I don't want it to do that, so I just fine, right? Okay. And similarly, it will be something like that. So it's something 9 to the power 3 is what, 343 or something.
729. 720. Lambda to the power 6
Okay, 7 to 29
by 8. 8 into factorial 3.
into lambda to the power 6, something like that, right? Next time.
Correct.
So what I said is, what is first moment? The coefficient corresponding to e to the expectation of x, right? So this is my first moment. The coefficient corresponding to expectation of x square is my, so this is my second moment, right? This is my third moment. This is my fourth moment. Correct? So okay, so if I compare, because both these things are same, right? This thing and this thing.
Should we go for one more expansion like?
Not required, I think. 1 minute, I'll just see. Coefficient of lambda. Okay, sorry. Okay, I'm sorry. So coefficient of lambda, actually, sorry, I did the wrong thing here. Sorry, this is lambda square. So coefficient of, actually, the coefficient of lambda is my first moment. So actually, this lambda is there and this is coefficient, right? Since expectation of x is also some kind of constant, right? So coefficient of lambda, this is first moment. Okay, expectation of x square is second moment. Sorry, not expectation of x square, expectation of x square divided by 2 factorial. So this entire thing is my second moment. Similarly, this entire thing is my third moment. And the coefficient of lambda to the power 4. So this thing is my what? Fourth moment. Correct, right?
No, sir. Lambda raised to 4 divided by 4 factorial we are keeping aside, na, and remaining thing we are using that value, na. That value what we are getting as the answer, it is other than lambda raised to 4 divided by 4 factorial.
Okay. I'm sorry. Yeah. So okay, this is the definition. I'm sorry, I just forgot this definition. It's so okay. The coefficient of lambda will give the first moment of expectation of x. Coefficient of lambda square by 2 factorial will give the second moment, right? And the coefficient of this thing is okay. Fine. I'm sorry. Okay, sorry for this confusion. Should I write it again or? I'm sorry.
Please write it again, sir, because yesterday
please.
we got a very good confusion in the same concept.
Okay, sorry. So expectation of e to the power lambda x is what? 1 upon so 1 plus lambda x.
Sir, just a general query.
Lambda x by 1 factor.
Sorry to interrupt.
Yeah, tell me. I'm writing.
Yes, sir. Yes, sir. I just want to check this. Solve with us will also be later available on YouTube, sir, because I just have a meeting.
Yeah, it is available.
Oh, we can see it after some time, right?
Yes. Fine.
Oh, thank you, sir.
Once this session will end, you will be able to. No, I
Oh.
think you can see anytime, actually. It's not a problem.
Oh, okay. We can click on link later and see it.
Okay, fine.
Thank you.
So, yes. Okay, e to the power. Sorry. I know that e to the power lambda x expectation of e to the power lambda x, which is nothing but mgf of x. And when in terms of if my x is a random variable, normal random variable, I know that this value is e to the power lambda square sigma square by 2, right? So but in this case, in our question, sigma square is 9. Okay. Now this consider this entire term as x. So I know the expansion of e to the power x. So it is 1 plus lambda square 9 by 2 divided by 1 factorial plus lambda square 9 by 2 square divided by 2 factorial plus that. So if I do the expansion of this, it will become 1 plus lambda square 9 by 1 factorial plus lambda square 81 divided by what this is 4 into 2 factorial. Okay, so it's lambda raised to 4, right? And so on. And what is my definition here is the first moment will be the coefficient of lambda. Second moment will be the coefficient of lambda square by 2 factorial.
We
Third
need
moment
fourth
will
moment, sir.
so the third moment will be the coefficient of lambda cube by 3 factorial, and fourth moment will be, so my fourth moment will be coefficient of what, lambda to the power 4 upon 4 factorial, right?
That
So
should be the next term, no, sir.
which one?
First is 1 plus
Term, sir.
1 factor.
Lambda power 4.
So okay, what is the next term here in this sequence? Lambda to the power 6
729
upon 8 into 2 factorial, correct? And
8 times 3 factorial.
Okay, something like that, yeah.
Sir, before that one, what is the fourth one? Is the fourth term is the fourth moment, or lambda power 4 is the fourth moment?
No. The coefficient of lambda to the power 4 divided by 4 factorial. This is
That's
my
the fourth moment?
Yeah. So so first, where is my lambda to the power 4 in this equation?
Third term.
This term, right?
Yesterday on this concept, actually we got a very good discussion, sir.
Okay.
Because it couldn't be always even terms.
Yeah, it can be anything, right? So it's okay. So
Means the third and the fifth and the seventh moments are also possible.
so yeah, so in this case, which moments are possible actually? So
All 1, 2, 3, 4,
Even
5.
moments.
first moment is not possible, right?
All 1, 2, 3. No.
Actually, see, this is I did not write expectation here. Okay, but if you write also expectation inside, it will become lambda
E of
into,
R is not possible.
Huh?
Expectation of first term E1 is not possible.
No, it is one only, right? Okay, actually, okay, still I think okay, go. Okay, I'm writing it again. Just see once more properly. Okay. So this is nothing but expectation of what, 1 plus lambda x plus
Lambda x divided by
lambda square
lambda square.
Lambda cube x cube by 3 factorial lambda to the power 4 factorial, and like that, right? That's okay. So if I'll expand it, it will become 1 plus lambda into expectation of x. Then it will become lambda square by 2 factorial into expectation of x square plus lambda cube upon 3 factorial into expectation of x cube plus lambda to the power 4 upon 4 factorial into expectation of x to the power 4 plus so on. So in this case, what is my first moment? The coefficient of lambda. So this is my first moment. Okay. What is my second moment? The coefficient of lambda square by 2 factorial. So this is my second moment. What is my third moment? The coefficient of lambda cube upon 3 factorial is my third moment. And the coefficient of lambda to the power 4 upon 4 factorial is my fourth moment. Okay. Understand? So these are my fourth moment. So first to fourth moment and so on. Now I know that this expectation of e to the power lambda x for a normal random variable is what? E to the power lambda square 9 by 2. So how can I write this expansion? 1 plus lambda square 9 by 2, not 2 factorial. The 2 factorial is the same, but okay, fine. Okay, I'll write it in this fashion. Is it okay?
That's always better, sir.
So then next one is lambda to the power 4
by 3 factorial in
Sir, for the first one, it should be only 2. Na? I mean, because of that
Yeah.
sigma square by 2.
Actually, yeah. So it should be lambda square 9 by 2 upon 1, right?
Uh,
Okay, e to the power x, what is this expansion? 1 plus
yeah,
x
upon 1, yeah,
by
right.
1 factorial
X
plus
by 1 factorial, x square plus 2 factorial.
x cube by 3 factorial. Replace this x with what? Lambda square 9 by 2. So it will become lambda square 9 by 2. So eventually it will become lambda square 9 by 2 factorial or 2. Same. Okay. That is okay.
Yes, sir.
Instead of x, if I write lambda square, so here it will become lambda square 9 by 2 to the whole square divided by 2 factorial, correct? So this will become lambda to the power 4 81 upon 4 into 2 factorial, correct?
Yes, sir.
Okay. Similarly, x cube will become what? Lambda square 9 by
Lambda
2
power
cube.
6.
So it will become lambda power 6 729 divided by 8 into 3 factorial. Fine.
Yeah.
So going with this way, I actually I don't wanted that lambda to the power 6 actually in this question, but I'm just writing in for understanding purpose only. So let's say, okay, let's remove. Now first term will be what? Lambda square 9 by 2, but this 2 I can write as 2 factorial, right? Because anyway, is it going to change any values?
No, it's right.
No. So so next term will be lambda to the power 481 by 4 into 2 factorial, correct?
Yeah.
And the next term will be lambda to the power 6 729 upon 8 into 3 factorial.
Yeah.
So I just wanted this term, na? Fourth
no,
moment.
sir, the next term, the next term.
No.
No, only the lambda, the third one in this case.
Yeah. So listen to me. What is my
The
fourth?
denominator should be having 4 factorial, sir. K factorial, I mean to say.
So okay. We wanted, but the fourth moment is related to which term? Which lambda term? This one, right? Lambda to the power 4, right? So if you go ahead of this, if you go ahead in this expansion,
Okay, now I understood, sir. Thank you.
The next term will become what? 8, right?
Yes.
And some numbers, correct? So in this case, what is happening? Which moments are we getting actually? In this case, we are not getting this first moment because we don't have the term of lambda, right? Na?
Only one moment we are getting.
So, we are getting the second moment. We are getting the fourth moment. We are not getting third moment also because we don't have this term lambda cube. And next also we won't be having the terms lambda to the power 5, lambda to the power 7. So we are just getting moments which are even. So and I know the fourth moment is related to which coefficient. So
We need to remove lambda to the power 4 by 2 factorial, and the remaining would be the.
Yeah. So we have to convert that lambda to the power 4 by 4 factorial. So what is 4 factorial? 4 into 3 factorial?
24.
Or I can say 4 into 3 into 2 into 1, right? And in this case, we have only 4 here and 2 factorial is here. So we have to just multiply this term with 3, right? In the numerator and the denominator.
All right, this is the trick we need to do.
So if you do this, then what will happen? Lambda to the power 4 into 81 into 3 divided by this. What is this? 4 into 3 into 2 factorial. It's 4 factorial.
24.
So that means it's 4 factorial, right? And the coefficient corresponding to this, right? The coefficient corresponding to this is my
Answer.
So expectation of x to the power 4 is equal to what? 81 into 3 is 3 and 243. Right?
Sir?
We got to get lambda power 4 by 4 factorial, is it?
Yes.
Sir? Does it mean that in this case we will never get fifth moment or seventh moment or ninth moment?
No.
Right, sir. Right, sir.
We are
Yeah, sir,
only
that's correct. Yesterday we got the confusion on this particular part only. Now it is clear.
fine, right?
So, sir, we will never get that, right? Fifth, seventh, ninth, third, we will never get, huh?
In this case, what I'm saying is in this case, if something else is
Was there
there,
any class yesterday?
Voice is not audible.
Sigma square is lambda, then we'll get sigma square is equal to lambda, then we'll get cubic terms.
But in this case, we will not get, right?
This case is not.
Yeah, in this case we'll not.
Yes. Thanks, sir.
Okay. Done. Okay, I think shall we close?
Was there a class yesterday?
No, he is talking. He is referring Sunday.
Sundays maybe. Yeah.
He is referring Sunday class.
Okay. Thank you.
Okay.
Not there in the
Hello,
class,
sir.
sir.
Okay, I think that's it. So you guys can go
Sir,
through.
1 minute. I have one doubt, sir.
Okay.
In second question, can you just go to that answer part?
Second one.
Yeah, here, why are we subtracting 100 mu from 220? Because as per formula, it's just delta into under root n mu by sigma.
Okay.
Here, why are we subtracting?
Okay, so don't go don't use that formula as it is. That is different one actually. So if you think about this formula, right? I know. So basically,
So your voice has gone really very down, sir.
Yeah. So basically, the central limit theorem is not this one. So what is this? Y minus delta n mu, right? Y minus. So actually, this.
Yeah, this one.
Yeah, sir has used y minus n because sir found out the probability of y minus n mu is greater than delta n mu. But basically, your central limit theorem is this one. Y minus n mu upon root n. This approximates to, sorry, this one. Y minus n mu upon root n sigma is approximating to 0, 1. So when you wanted to find y minus n mu greater than delta n mu, this is okay. But what we are finding here in this case, we are not finding y minus n mu greater than delta n mu. We are finding y is greater than 220. So that delta is only 220. So if you are going to consider that formula, right, then delta n mu will become what? 200 into what? 100 into something like this.
Sir, how to understand which formula to use?
No, that's what I'm saying. Don't like think too much about this. Okay, so this flow of question should be solved by, okay, what we wanted to find. Okay, I'll tell you which formula. So just
But in the formula sheet, you won't get both the formulas. No, formula sheet has only central limit theorem y minus n mu divided by.
Okay, so this formula is important.
That is not in the formula sheet. Oh, this is there.
Yeah, so because this is normal, this is approximates to normal 0, 1. So whatever things are there, right, you have to convert into this. So in our case, what was there? X1 square plus x2 square plus x100 square is greater than 220. So consider this entire thing as what?
Y.
So I wanted just y is greater than 220. So how can I convert this thing into this?
Okay.
So y
So
minus.
always we have to convert it and then only use it, and not the direct formula.
Yeah, you have to convert into this form because this approximates to your normal 0, 1. So don't follow that formula which your sir is directly given, right? So that is actually it's not incorrect, but that is a different reference point. If you go through the lecture, because here the probability which is asked is probability y minus n mu upon delta n mu. So finally, what sir did is he has converted this y minus n mu thing into what? Y minus n mu upon root n sigma. So when he tries to convert this y minus, so left hand side into this becomes.
Okay. Right, got it.
So basically, this is the formula you have to convert.
Okay. Thank you.
Sir, can you come to writing pad, sir? Can you come to writing pad, sir?
Okay.
Just now you're writing something, right?
Where?
No, writing pad. Yes, sir. Sir, it may be a very trivial doubt, sir, but I'm not able to connect. In week 4, I think we had discussed that, while standardizing it, we were using the formula x minus mu by sigma, right? I had just a small disclaimer. I had asked this question Sunday also, but I could not get the right answer. It means I could not get it properly. In week 4 or 5, we studied a formula that, in order to standardize it, we use a formula. You can write it down: G equal to x minus mu by sigma. G equal to x minus mu by sigma, right?
Right. So we are
So
doing
how
actually,
these two are?
yeah, we are actually doing the same thing, right? Okay, I'll tell you how. So this y minus nb upon sigma root n is nothing but you're standardizing it only. So
Yes,
I'll tell you how. So let's say my x1, x2 to xn, right, is belonging
Right.
to some distribution. I don't know which distribution, but yeah, for now this is x. So uh, what you were doing in that fourth, right? You are
Yeah, week
subtracting,
4.
yeah, expectation of this, and you are dividing it by
Sigma.
standard deviation of y,
Sigma. Yes.
of y, right? So if my y is my random variable, so in this case consider y as x1 plus x2 up to xn.
Hmm. Hmm.
Okay, now y minus, what is expectation of y here? So expectation of y is expectation of x1 plus
Correct.
expectation of x2, like this. So it will
Yes.
be n times expectation of, or xi, which is n times mu. Can I write n times mu here?
Yes.
Okay. Now, what is my variance of y?
Uh, Variance of x1 plus variance of x2 plus variance of x3. Yes.
So it will become
N into sigma square. N into sigma square.
divided by,
Divided by, how to divide it?
okay, n into sigma square, right? Okay, fine. So it will become n into sigma square, right? So I wanted here what?
Standard
Okay,
deviation.
sorry, not n into sigma. So what? This
Yeah,
is what?
got it. Got it. You're right, sir. It is yes, that is variance. Yes.
Is it not the same what you have studied there? Same, right?
Correct.
Hmm.
Yes. Thank you, sir. Thank
This
you, sir, for
formula,
deriving this formula. Thank you
yeah,
a lot.
this formula is same, but why this become like this? Because we are considering this y as a sum of n IIDs.
But still that part is not clear, sir. That
But now
delta
it's
n.
clear,
Okay,
right?
I will go through it again. I will not trouble you at this point of time. That right hand side delta nu by how that is getting
Okay,
converted into.
this is nothing. You, I think, okay. You understand this part, right? What is this?
This part is crystal clear. Yes.
Yeah. Okay. You can go to the lecture again, and what sir is
Yes.
trying to do, right? Just check it once.
Yes. Yes.
Okay.
This part is clear, but in that right hand side, delta nu by square root n.
Okay. Okay.
That part is
Okay. So okay. Let's say I wanted to find probability that let's say delta n mu. Hmm?
hmm.
Hmm? Or
Hmm.
I no. Okay. Sorry. I'm sorry. So I just wanted to find this probability. Okay. And I don't know how to find. I just asked, somebody has asked me to find by using the CLT. Now I know I have to convert into this format, right?
Hmm.
Is it? That's okay, right? Because
Correct.
this is Z.
Yes, yes.
This is normal 0 1. So when I come to this format, I'm able to relate it to normal distribution, which is standard normal distribution. So in this
Yes.
case, uh, okay, okay, how is it looking this term? Is it okay? Is it not similar, right?
No.
But if I wanted to convert it into this kind of shape, what I have to do is, because my numerator is there as it is.
Right. So denominator we have to
What I have to
divide
do,
both sides by sigma root square root n sigma.
right? So if I do that, y minus n mu upon root n sigma, and I have to do here also, right? So it is delta n mu
Delta
divided by root n, sorry, root n sigma.
sigma. Yes, yes, correct. And that delta will be there. Yes, yes.
So delta is there. So this root n is into the denominator, right? So
Right.
that, and numerator is n. So n divided by root n is what?
Root n in
Root n,
numerator.
right?
Root n in numerator.
So,
Correct.
okay. So this is what?
That is G.
Z?
Standardized, yes, G.
So that means probability that Z is greater than delta mu root n
Square
by
root n. Correct.
sigma. Is it okay?
Yes.
And what
Yes,
is
yes.
this probability of Z is greater than this term means what? Fz of
1 minus
1 minus Fz of
delta mu square root n by sigma.
okay. So this is what we have derived. Is it not the same here? Delta root n mu by sigma.
Correct. So this is in the formula, right? Yes.
So basically this delta n is some constant because delta is constant, right? A smaller number. N is what? Number.
Number
So
of
it's
sample.
constant. Yeah, so it's constant. Mu is constant because it's a
Yes.
distribution mean. So this becomes some constant. Let's say delta is 0.1, n is 100, and mu is 2. What is the value of it? 0.1 into 100 is
30.
10.
Correct.
10
20.
into 2 is 20. And n is what?
But n is 30 means whatever number of sample is.
Yeah. So see, finally, where you have to come, whatever probability it is asked, right? And if you wanted to convert it into CLT, the format of your left hand side should be like this.
Correct. Yes.
How you are going to come to that side, it depends on you. So once you
But in right hand side, when we are talking about greater than 220, so why we are not taking delta as 220? Like whenever we are saying greater than 220, right?
it is not, it doesn't matter, right? Whatever is that right side. What I'm saying is delta n mu is something constant, right?
Correct.
So that constant can be anything. See, okay, one more thing. Okay, I'll try to do one more thing. Let's say if you don't understand that also part, let's say this is.
So this part is clear. Yeah.
No, okay. I'll try once more. Provided that y minus n mu is greater than delta n mu, is it not same as y is greater than delta n mu plus n mu?
Correct.
Is it correct? And let's say I said this delta n mu plus n mu is 220. How you're going to find? Right. So similarly, if I convert it into this format, y minus y is greater than this something. So all are this constant, right? Delta n mu plus n mu upon some. So okay, in this case, how we are going to find the answer? Probability that y is greater than delta n mu plus n mu. In this case, what are you going to do? Next step, you have to subtract mean.
Expected value of y, yes, mean.
So it is n mu.
Yes. By sigma.
So by sigma. So same thing
Yes.
I have to do sigma root n, right?
Yes, sigma root n.
So I have to do same thing on the left right hand side. So delta n mu plus n mu minus n mu is what?
Delta n mu.
Delta n mu divided by sigma root n.
Yes. Sigma square root n.
Same.
Correct. Yes.
So don't look this equation as y minus n mu greater than delta n mu. Look it as probability that y is greater than delta n mu plus n mu. Anyway, this value is some constant. And consider this 220 as this value.
Okay, 220 is the entire expression.
Yes. Okay.
Okay, sir. Thank you, sir.
Okay, guys. Bye.
Sir, some more exercises have been given in this week, kind of thing, sir. When we will be knowing about the answers for that one, I mean, solutions?
For what?
Yeah, two exercises, new exercises have been added for this.
Reflection assignment something, is it?
Not like that, sir. Direct, some more questions have been discussed, I think.
Where?
For solving. In the same portal, sir.
I'm not sure. Can you tell me where it is?
There is extra activities, no?
Extra activity is different. Extra activity is
No, not extra activity, sir. For this particular.
We keep nothing is added.
I don't think it's like it's not in my. Nothing is there, I think.
Yeah, tutorial 1 not graded, tutorial 2 not graded, sir.
Those are the tutorials.
After graded.
Every week we have tutorial 1, tutorial 2, right?
Yeah. But you have a solution of most tutorials.
Yeah, we have. You have, right?
You can just put the check answers, you get the solution, then you can understand.
Okay.
Okay.
Okay, guys. I think. Okay, bye bye. Good night.
Sir, quiz 2 will be up to week 8, right?
Yes, we get yes.
Quiz 2 is
Quiz 2, yes.
Up to week 8. Up to week 8. And we are submitting assignment for week 9.
No, week 8 only, sir.
No, week 9 is already in.
So
It's
next
already
Wednesday,
Yeah.
not this Wednesday. Tomorrow you have to submit week 8.
Tomorrow week 8, we are supposed to submit week 8, yes, tomorrow.
Yeah, and before the quiz 2, we are submitting week 9 also.
That's what.
Yes, yes.
Okay.
Yes, yes.
Okay.
That is the difficult thing.
Okay, guys. Bye bye.
Okay, thank you, sir.
Right, thank you, sir.
Yes, sir. Thank you. Thanks a lot
Thanks a
for
lot, sir, for
clearing
this.
our doubts.
Yeah, you derived a lot of formula. Thank you, sir. Yes.
Thank you.